Good morning, Internet. I am Matt Buyak, and in this video we'll be taking a look at the 40th problem from the Project Euler problem archive. And this problem asks us a question about Champernowne's constant, which is formed by concatenating all of the natural numbers all the way up to infinity, and then adding a leading decimal point. And the question asks us to find the first, 10th, 100th, 1000th, 10,000th, 100,000th, and millionth digits of this constant, and then to find their product. Now, I think we can solve this problem in a pretty straightforward way, so let's get started. As usual, we will copy our template directory to make our problem directory, and open our main.cpp. Okay, I think we will need a string to keep track of all these digits. So let's just include string. And we'll need to keep track of our solution. It's a product, so we initialize it to 1. As I said, we need a string. Let's call it str. And then let's just append digits until we get up to 1,000,000. So we'll say int n equals 1, str.length is less than 1,000,000, increment n. And then we'll just say append to string. And we're going to convert n to a string and append it to our string representation of Champernowne's constant. Okay, so now we just need to get all of the digits that are required for our solutions. So let's say for int n equals 1, n less than or equal to 1,000,000, multiply n by 10. And we'll say solution, we're going to multiply it by the n minus first digit of our string. That's because there is an off by 1 error that we need to be sure to avoid. The first digit has offset 0, the 100th digit has offset 99, etc. So we need to be sure to do -1 here. Okay, and then we just subtract the ASCII code for 0 to get the digit itself. And now we can just printf solution is %d solution. And that's our solution. Except that's horrible. Like, this is horrible. Like, why would you do it this way? You're allocating a full megabyte and writing all these digits that you don't even care about. Like, these days we can almost get away with something like this, but back when this problem was written, you would never dream of doing something so wasteful. So maybe let's see if we can come up with something a little bit more clever. We'll start by opening our analysis file. I apologize a little bit for trolling you with that initial solution. So our approach here in being a little bit more clever is we're going to take our constant and divide it up into sections, where each section has all of the natural numbers with a particular length. So section 1 will be all the 1-digit numbers, section 2 will be all the 2-digit numbers, section 3, 3-digit numbers, etc. And we'll iterate over each section and determine the offset to the beginning of each section. And when we see that the offset for our current section is less than or equal to a target digit, and that the offset to the next section is greater than the offset to our next target digit, then we know that we have a target digit in the current section. And then since all the numbers in a particular section have the same length, we can just divide the offset within that section by that length to figure out what natural number contains our digit. And then the remainder of that division will give us the offset within that natural number itself. As is often the case, it's usually best to go through an example. So let's find the 1000th digit. And I'll just note that's offset 999. Our starting solution that I showed you was a bit of a joke, but it did contain a couple of true points, one of which is that we have to make this distinction between the, for example, thousandth digit and the 999th offset. There's an off by one error to be avoided. Okay, so let's put a little table together here. We're going to keep track of our current section, and we'll want the offset to the beginning of that section. We'll want to keep track of the smallest element in our current section, which is just going to be a power of 10. And then we'll want to calculate the section size for our current section. That will let us determine the offset to the next section. Okay, so we're starting at section 1. It has offset 0. The first element in section 1 is 1. And the section size is going to be 9. And we can determine the section size. We'll just say note. Section size is going to be equal to 9 times the power of 10 times the section that we're in. For example, if we were looking at section 3, the section which contains 3-digit numbers, the smallest 3-digit number is 100. We multiply by 9 to give us the total number of 3-digit numbers. There are 900 3-digit numbers. And then we multiply by the length of each number, which is 3, to get the total number of digits in that section. And we can repeat this process. So we have section 2 is going to have offset 9, just adding the section size to the offset. Power of 10, we just multiply by 10 to get the next one. And then section size is going to be 9 times 10 times 2, which is 180. Section 3 is going to have offset 189. And the smallest element with length 3 is going to be 100. And then the section size is going to be 3 times 9 times 100, which is going to give us 2700. And now we can see, we'll say note, 189 is less than or equal to 999, which is less than 2700. So our digit is in section 3. Let's see. In particular, the number which contains our digit will be, and that's just going to be 999 minus 189 to give us the offset within section 3, and then we're going to divide by 3 to give us 270. But recall, that's only the digit as or the number relative to the first element of the section, and so we need to add 100 to get 370, which is the number which contains our digit. And I'll just say, note that because 3 divides 810 evenly, we want the first digit. That is, our digit is 3. And if the section number did not divide the section offset evenly, then it would be the remainder that would determine which digit we need. Okay, so let's get to writing some code. Some more code, that is. Okay, so let's grab our main prototype here, and let's disable this section of code. Okay. And we'll probably want variables for each of these values here. Section starting at 1, offset starting at 0, let's see, power of 10 starting at 1, and our solution is going to start at 1. And we're going to want an array that holds each of our target offsets. So we're going to say, let's see, array. Let's actually make this static and constant. It's going to be an array of 7 integers. Call it target offsets. That's going to be 0, 9, 99, 999, 9999, 99999, and yeah, a bunch of 9s. Like so. Okay, so now we're going to want to iterate over our target offsets. So we'll say for int digit offset is going to be an element of target offsets. One minor optimization, we could, for each digit that we're trying to determine, start over from the first section and iterate over the sections until we find our target section. But if we have our target offsets ordered in ascending order, then we can just iterate over the sections once rather than doing that iteration for each target digit, repeating the process 7 different times. Okay, and so now we'll say section size is just going to be as we discussed over here. That's 9 times our power of 10 times our current section. Okay, and then we say for offset plus, while offset plus section size is less than or equal to digit offset, we're going to iterate over the sections. So we just need to update each of those values just like we did in our example. We'll say plus plus section, PO10, multiply that by 10. Offset, we're going to add the section size. And then we need to calculate the new section size just as before, 9 times PO10 times section. So now at this point we have found a section that contains the next target digit. So we'll want to determine the offset within that section rather than the offset from the beginning of the constant. So we'll say section offset, that's just going to be digit offset minus offset. Okay. Then we want to determine the natural number in which our digit lies. So we'll say int n is going to be section offset divided by section plus PO10. Again, just as we did in our example over here where we had to add 100 to get our number here. Okay. Now at this point, while extracting digits from the least significant end of an integer is relatively straightforward, we just would divide by 10 and look at the remainder. Extracting an arbitrary digit is a little bit more involved, and so we're just going to convert the thing to a string, and that's going to make it easy to get the digit that we need. So we'll say string str is just going to be to string n, and then we can do solution. We're going to multiply that by our digit, and so that's going to be str section offset mod section. And then we have to subtract, as before, the ASCII code for 0. And I believe that's it. So we'll say solution is %d. And go back to our shell and make... I neglected to include array. And we get the same answer as with our first approach. So let's go back to our browser here and take a look at the archive. And we see that that does, in fact, match our solution. So thank you for joining me in this video. And in the next video, we'll be covering problem 41. I hope you'll join me.